Recall that the product rule for derivatives states that if f and g are differentiable functions, then the derivative of the product, f of x times g of x, is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function. So that is the product rule, and in this video we are going to use this to find some derivatives. So let's find derivatives of the following functions. F of x equals x cubed cosine x, g of theta equals e to the theta sine theta plus pi to the fourth theta, f of t equals 4x to the fifth natural log of x plus 2x, g of x equals 10 times the cube root of x times x cubed minus 4e squared, and finally h of x equals x squared times 1 over x to the fifth plus 3x e to the x. So I would like you to grab a piece of paper, pause, and try each of these on your own. Do get out a piece of paper, don't just do these in your head. And use the product rule when necessary. If there are any situations where you could do it with the product rule or could do it an easier way, feel free to do that. So try those out. We'll talk about it in a moment. Okay, our first example is f of x equals x cubed cosine of x. So there is a product there. Those two things are multiplied together. And so the derivative, f prime of x, is equal to the first function times the derivative of the second, that's negative sine of x, is the derivative of cosine of x, plus the second function, that's cosine of x, times the derivative of the first, the derivative of x cubed is 3x squared, and so we would probably want to simplify that and rewrite it a little more nicely. That's negative x cubed sine of x plus 3x squared cosine of x. It's traditional to write the polynomial in front of the trig function. It's not technically anything different or anything incorrect to write it the other way. That's traditionally how it is written. Okay, g of theta is equal to e to the theta times sine theta plus pi to the fourth times theta. So let's take each of these separately. We know that the sum of the derivatives is equal to the derivative of a sum is equal to the sum of the derivatives. So we can look at each of these pieces separately, e to the theta sine theta as one piece, and look at pi to the fourth theta as a second part to take the derivative of. So g prime of theta, the first derivative, is equal to first our first function, e to the theta, times the derivative of sine theta is cosine of theta, plus the second function, that's sine of theta, times the derivative of our first function, that's e to the theta. So derivative of e to the anything is just e to that anything. So that is the derivative of the first piece. Now let's take the derivative of this piece. So plus. Now pi to the fourth theta. We could think of that as a product, but what is pi to the fourth? Notice that pi to the fourth is just 3.14159, blah, 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 to the fourth power. That is a constant. And so we can just use the constant multiple rule. This is equal to pi to the fourth, that constant, times the derivative of theta. The derivative of theta is simply 1 because theta is the variable, just like x is a variable. And so this is just simply pi to the fourth is the derivative of that second piece. And so that means that g prime of theta is equal to e to the theta cosine theta plus e to the theta sine theta plus pi to the fourth. One thing to note here is that if you're using the rules correctly, you can still use the product rule if you want on something like pi to the fourth theta. So if we take the derivative with respect to theta, the variable of pi to the fourth times theta, and we said, oh, okay, I think I need the product rule on that, we could do that. And so we'd have The first is pi to the fourth times the derivative of the second. The derivative of theta with respect to theta is 1, just like the derivative of x with respect to x is 1. And again, we can see that either, say, using the power rule or the definition that the derivative of a linear function is its slope. If we wanted to use the power rule on that, just to illustrate again, being able to, we haven't finished this yet, being able to use rules wherever they are valid, we could use the power rule on this. This is 1 bringing down the exponent times theta to the 1 minus 1. That's 1 times theta to the 0. And what's theta to the 0? Anything to the 0 is 1, so this is just 1. So yeah, whether we use power rule or just knowing that the derivative with respect to a variable of that variable is 1, either way, we get that the derivative of theta is 1. Okay, so we were using the power rule on this. So this was, so far, the first times the derivative of the second. Now we're doing plus the second, theta, times the derivative of the first. What's the derivative of pi to the fourth? Again, pi to the 4 constant implies that the derivative is 0. Why is that? If we think about pi to the fourth and just graphing it, so pi to the fourth power, it's, something like, 30-ish, but it is flat, right? F of theta equals pi to the fourth, and that is flat. The derivative is 0 because the slope is 0. So the derivative of that is 0. And so what does that all simplify to? That all simplifies to pi to the fourth times 1 is pi to the fourth, plus something times 0 is 0. And so we get pi to the fourth, just like we did up here above. So this is just illustrating that that any derivative rule used correctly is okay to use. It's just that some take longer than necessary. So we did not need the product rule on that, but we could use it if we wanted. Okay, let's look at the derivative of f of x is equal to 4x to the fifth times natural log of x plus 2x. So f prime of x, we're going to use the product rule on this first piece. Here is our first, here is our second. So this is the first is 4x to the fifth, not taking derivative, just writing it down, times derivative of natural log of x is 1 over x, plus the second is natural log of x times the derivative of the first. The derivative of 4x to the fifth using the power rule is 4 times derivative of x to the fifth is 5x to the fourth. And then now we want to also take the derivative of that second piece of 2x. So the derivative of 2x is simply 2. The derivative of a linear function is just its slope. And so now we could continue by simplifying that if we wished, or we should simplify that. So 4x to the fifth times 1 over x, that's 4x to the fourth, because if we think of x to the fifth times 1 over x, that's the same as x to the fifth divided by x. And we could either use exponent rules for that, knowing that x to the a over x to the b is x to the a minus b, or, we could observe that x to the fifth is x times x times x times x times x, 5 times divided by x. When we divide, we get rid of one of those x's, get rid of one of those x's, and what do we have left? That's x to the fourth. So, we don't necessarily want to have to do this every time. We should use, in general, know that rule about exponents, that x to the a divided by x to the b is equal to x to the a minus b. So 4x to the fifth times 1 over x is equal to 4x to the fourth power. And so this is plus, now we've got 4 times 5, that's 20, x to the fourth times natural log of x plus 2. And so that is our final solution. Okay, g of x is 10 times the cube root of x times x cubed minus 4e squared. So again, we're going to start by simplifying this. We could use a product rule for these two, But instead of using the product rule, we are going to simplify that to not have to use it. So we're going to rewrite g of x. G of x is equal to 10 times, so cube root of x is the same thing as x to the 1/3 power times x cubed minus 4e squared. And now let's, on the side, if we need to, simplify that x to the 1/3 times x to the 3rd. Remember that in general, it's the case that x to the a times x to the b is the same as x to the a plus b, and that's a really good rule about exponents to know. So this is the same thing as x to the 1/3 times x to the 3rd. To be able to add those two things together, we need a common denominator to add together 1/3 plus 3. So 1/3 plus 3, that's the same as 1/3 plus 3/3, plus 9/3, multiplying the top and the bottom by 3. So that's 1/3 plus 9/3, that's 10/3. And so that tells us that x to the 1/3 times x to the 3rd is equal to x to the 10/3. Okay, so now we can again continue to simplify g of x. We have not taken the derivative yet, so this is 10x to the 10/3 minus 4e squared. All right, so now we're actually ready to take the derivative. So g prime of x is equal to constant multiple rule, 10 times the derivative of x to the 10/3. Using the product rule, we bring down the exponent and multiply by x to the 10/3 minus 1. That's 10/3 minus 3/3, that's 7/3. So x to the 7/3 minus the derivative of 4e squared. Notice that 4e squared is a constant. It is a constant because e is just a number. It is not the variable in this equation. It is not x. There is no x in here at all, no x. And if there's no variable, that means that that thing is a constant. So this is just 0 is its derivative. And so now we could rewrite g prime of x. G prime of x is equal to 10 times 10, that's 100 over 3 times x to the 7/3. If we want, we could write that as a radical. So that is x to the 7th and cube rooted. So cube root of x to the 7th minus 0 is just 0. So last one in this video, let's look at h of x equals x squared times 1 over x to the 5th plus 3x e to the x. So again, instead of doing a product rule here, we are going to simplify this. So we're going to simplify this. And as we said above, so we've got x squared times 1 over x to the 5th. That's the same thing as x squared divided by x to the 5th. And we know that x to the a over x to the b is equal to x to the a minus b, x to the a minus b. So this is equal to x to the 2 minus 5. That means this is equal to x to the negative 3. So we are going to simplify that h of x before taking its derivative. H of x is equal to x to the negative 3 plus 3x e to the x. Okay, so now actually taking the derivative, h prime of x is equal to, using the power rule, negative 3x to the negative 4, plus, now we do need the product rule on this. So our first 3x times the derivative of the second, derivative of e to the x is just itself, plus the second, that's e to the x, times the derivative of 3x is just 3. And so we could simplify this. H prime of x is equal to negative 3x to the negative 4. If we wish, we could write that as negative 3 divided by x to the 4th power, plus, if we want, we could factor 3e to the x out of that, or not. So we could write that as 3e to the x times x plus 1 if we want, but we could also leave it basically as above sort of up to preference.